Morning, everyone. My name is Haikal Ramadhana Akmal with student ID 2009. In this, in this presentation, I will discuss about the Broncapture as a water intake structure, which are specifically designed to capture water direct from the natural springs. So we jump into the topic here. In introduction for the water intake structure. Water intake structure is fundamental component in water supply system that function to collect raw water from its source, such as river, lakes, or springs, and convey it to the treatment plant. The design of an intake structure must consider factors such as water quality, quantity, and fluctuation in water level, sediment load, and protection from debris. A well-designed intake ensures a continuous, safe, and efficient flow of raw water while minimizing the entry of unwanted material. So, bird capture in spring intake structure is specialized water intake structure used to capture and protect water from the natural spring, where the groundwater naturally flow to the surface. This type of intake is designed to maintain the original quality of spring water by preventing contamination from the surface runoff, human activity, and animals. The structure typically encloses the spring area, stabilize the flow, and direct the water into a controlled collection system because the spring water is generally clean and low in turbidity. Ground capture systems often require minimal treatment, making them highly efficient and suitable for rural or mountainous regions. However, proper design and maintenance are essential to ensure the sustainability and consistent discharge. So, type of burn capture in spring intake structure can be classified based on the how spring water emer- emergence and how it's collected. Each type of design to adapt to different hydrological conditions to ensure the optimal water capture and protection. The first one is burn capture for point spring. This type is used when the underground emerges from the single clearly defined point. The structure is built directly around the spring outlet to capture the water efficiently and prevent contamination. It is the simple and the most commonly used burn capture design. Next is burn capture for the diffuse spring. This type applied when the water seeps out, spread out, seep out over a wide area rather than a single point. A collection system such as pipe, perforated pipe, or gravel layer is used greater than what gather water and channel it into the collection chamber. For the burn capture with the infiltration gallery, this type uses a horizontal infiltration system to collect the groundwater before it reaches the surface. It is suitable for the area with a shallow groundwater flow and help improve the water quality of the natural filtration. Next is burn capture with the storage or reservoir integration. In this type, the burn capture structure is integrated with a small storage tank or reservoir. It is designed to regulate flow, store water temporarily, and ensure the continuous supply even when the spring discharge fluctuates. Now, the set condition for the selecting a burn capture. Burn capture is suitable only under the specific site condition where the natural springs are available and can provide a reliable and clean water supply. The selection must consider hydrological, geological, and environmental aspects to ensure that sustainability, water quality protection, and long-term functionality of the insect system. First one is the hydrological consideration. A burn capture system is suitable in area where the groundwater naturally emerges as a spring with the perennial and stable discharge. The spring must be able to meet design demand under a minimum flow condition in dry season. A proper hydrological assessment must include the flow measurement, seasonal fluctuation analysis, and recharge capacity to ensure the sustainability and avoid over the extraction. Next is geological consideration. Geo- Geologically, Broncapture is most appropriate in the area with the well-defined aquifer that discharge natural through the spring. Favorable conditions include the fractured rock, karst limestone, or volcanic formation, which allow groundwater flow and storage. Hydrogeologically, the aquifer must have sufficient permeability and storage capacity. The site must also be structurally stable to support the construction and prevent failure. Next is water quality condition. One of the minor advantages of the Broncapture is typically high quality of the spring water. However, the site must still evaluate to ensure that the water meet the raw water standard or require the only minimal treatment. Protection from the contamination is critical, as its spring water can be easily polluted if not properly managed. For the environmental condition, the protection is crucial to maintain the sustainability of the spring. The recharge area must remain undisturbed and a sanitary protection zone should be established to prevent the contamination. Land use activity around the spring significantly influence the long-term water quality. So, for the main design criteria of the Broncapture design must ensure that the spring water is captured efficiently without altering its natural flow regime or compromising the water quality. The design integrates the hydraulic, structural, and operational consideration to maintain the sustainability, reliability, and protection of the spring source. First one is the capacity in design discharge. The capacity is a burn capture system must be based on the safe yield of the spring, not the maximum observed discharge. The design discharge should consider minimum flow condition in the dry season to ensure the continuously, continuous supply without the over extracting which could damage the aquifer system. For the technical justification, the design discharge must be based on the safe yield on key minimum to maintain the natural equilibrium of the aquifer system. If the key design exceeds discharge capacity, it will reduce the hydraulic head, causing the decline in spring discharge or even complete drying. From a hydrogeological perspective, over-extraction disrupts the Darcy flow balance in the aquifer, leading to the long-term depletion. Therefore, the design based on the minimum flow ensures the sustainability and continuity of the supply. Next is the flow condition. The hydraulic design must maintain the laminar and controlled flow condition to prevent the disturbance of the sediment and avoid turbulence that could degrade water quality. Gravity flow is preferred to, to minimize the energy use and to maintain the natural condition. For the technical justification, the flow inside the Broncapture must be maintained at the low velocity, typically less than 0.3 meter per second, to avoid the turbulence and sediment resuspension. Based on fluid mechanics principle, higher velocity increases the Reynolds number, transitioning flow toward turbulence, which are disrupt fine particle and reduce water clarity. Additionally, stable laminar flow minimizes the head loss and prevent the air entrainment, ensuring efficient gravity-driven conveyance. For the sediment control, although the spring water is generally clean, fine particle or sediment may still be present. Especially during the rainfall event, the sediment control mechanism must be included to prevent the clogging and maintain the water quality. For, for the technical justification, even in spring system, filtration of fine particle can occur during the rainfall due to the increased surface runoff and soil erosion. Without sediment control, particles can accumulate and reduce effective volume, leading to clogging and increased heat loss in pipe. A settling chamber works based on the Stokes law where the particles settle under the gravity. When the flow velocity is sufficiently reduced, thus the improving water quality and system efficiency. Next is for the structural component. A brown capture structure typically consists of a collection chamber, impermeable protection wall, intake pipe, overflow system, and cover. The structure must be watertight to prevent contamination and designed to withstand soil pressure and environmental loads. For the technical justification, the structure must be watertight to prevent contamination through the infiltration of the surface water, which often carry pathogen and pollutant. The use of the impermeable material ensures no external hydraulic connection except through the control inlet. The overflow system is necessary to maintain hydraulic stability, preventing the ensure build-up that could damage the structure or alter natural spring flow path. Then the last one is operational aspect. Operational design must ensure ease of the maintenance, monitoring, and long-term functionality. Since Broncapture systems are often located in remote areas, simply and reliability are the key priorities. For the technical justification, a simple and passive system, gravity-based, mechanical part, reduce the probability of the mechanical failure with the low failure rate and minimize the operational cost. In remote areas, complex systems increase downtime due to limited maintenance capacity. Regular monitoring ensure the early detection of the change in flow rate or water quality, which may indicate aquifer disturbance for the contamination. I think that's all from my explanation. I hope you learned something new today. Thank you. Assalamualaikum warahmatullahi wabarakatuh.